to get to how we got to these crop circles in the first place and why I'm talking about this in relation to unified field theory, you have to go back to Nassim's personal experience going to Mexico and seeing structures like Chichen Itza, and here's Teotihuacan, these very structured pyramidal architecture that's laid out in a specific way, and relationships. And at the end of the career of an archaeologist, Peter Tompkins, who was studying this city, he concluded that what the Mayans and the Mexicans were trying to tell us with their pyramids is that there's a relationship between a sphere and a tetrahedron. The tetrahedron, of course, is the simplest of the 5 Platonic solids. And if you put a tetrahedron inside of really the most basic, most fundamental structure that the universe makes, the universe is making spheres at all scales. Galaxies are essentially spherical with a accretion disk, and the stars go up into the halo and back down and then out, and making a toroidal structure. A dual torus is basically a sphere. And so we're talking atoms, we're talking the energy around our bodies being spherical, the Earth being a sphere. No, it's not flat. Thank you very much, flat Earth. Galaxies being a sphere, the universe being a sphere. It's embedded, spheres inside of spheres inside of spheres, fractally to infinity. So it's pretty interesting that they were telling us this relationship in their pyramids, because if you put a tetrahedron in a sphere, it intersects the sphere at 19.47 degrees latitude, and you see that encoded in not just the pyramids, but in structures on our sphere. If you put a tetrahedron inside the Earth, the largest mountain on the planet is the big island of Hawaii, and that city, Teotihuacan, is actually on 19.47 degrees latitude, telling you that not only were the Mexicans and the Mayans and the Aztecs aware when they were building their pyramids of the relationship of the sphere and the tetrahedron, they knew where they were on the Earth. And so they probably did know that they were, on a sphere. So no, Christopher Columbus didn't discover America and discover that the Earth was round and all this stuff. I literally was told that when I was a kid. It's part of why I do these lectures, right? I want to undo some of the incorrect education that I received and my colleagues and my classmates, right? And so Nassim is looking at the tetrahedrons and says, okay, tetrahedrons are probably having something to do with the structure of the vacuum, because it's the most foundational, most well-constructed and solid geometry that there is. With 6 lines, you can make a 3-dimensional geometry called a tetrahedron, a 4-sided object. Each has an equilateral triangle on it. And so if you put a bunch of these together, you could make a larger tetrahedron out of 20 smaller tetrahedrons. It's what Buckminster Fuller discovered and described as the isotropic vector matrix. And if you take 2 isotropic vector matrices that are 20 tetrahedrons each, one pointing up and one pointing down, you get this, you get the star tetrahedron, okay? You've all heard of the Merkaba or the star tetrahedron. Well, inside of a star tetrahedron, made of 40 total tetrahedrons, you get this geometry in red, which is a cuboctahedron, and this geometry is in a perfect vector equilibrium. It's a perfectly balanced geometry. This is the kind of geometry you would need to find if you were to describe a scalar fractal geometry that gets larger and larger. And so Nassim looks at this, he says, let's put more tetrahedrons onto the outside of this to see if we can get to the next octave. And at a total of 64 tetrahedrons, you get a cuboctahedron inside of a cuboctahedron. 2 octaves of perfectly balanced geometry. The kind of geometry that would account for the fact that space is full, even though we perceive it as empty, because no matter where a force comes from, there's an equal and opposite vector in that geometry that's at the same length as the other one. And all those vectors from the center to the edge and the edges are all the same length. It's like putting 8 star tetrahedrons together. And so this geometry, the 64 tetrahedron grid, is foundational to Nassim Harameyn's unified field theory, because it's the fewest number of tetrahedra that you need to put together to get the first octave of what is an infinite fractal series of perfectly balanced geometry, creating this thing that we call space that's sitting there in perfect balance. It's like being in a swimming pool with water molecules everywhere. And no matter what scale you're at, you can get this spinning vortex to form like a whirlpool in the bathtub that we're in. We're in a giant bathtub, basically. It's made of space-time, and space-time is quantized. It's not just a continuous thing. You can think of space-time like Einstein's equations talking about space-time curving and like this, and you think of it as a smooth surface, just like when you pull the water out of your drain and the water goes down, it's not just going straight down, it's actually curling as it goes down. And so Sim added the math to make Einstein's curvature of space-time be the curling of space-time, including the fact that everything is spinning, right? Atoms, planets, galaxies, the universe itself, all spinning. There's nothing that's not spinning. The energy field around you is spinning. You're made of 100 trillion cells, each one of those made of trillions of atoms, and they're all spinning at the speed of light right now. They will not slow down ever. Protons have been spinning since the Big Bang and never slowed down.